This is 1-7 function notation. Some sets of ordered pairs can be described by using an equation. When the set of ordered pairs described by an equation satisfies the definition of a function, the equation can be written in function notation. So all function notation is replacing y with f of x. Okay, that's how you pronounce this. Is f of x. Okay. Function notation is super duper helpful because it makes it more clear what values we're plugging in for x. So for example, if we have f of x equals 5x plus 3, and instead we have f of 1, that tells us that wherever there's an x, we're going to plug in 1. So we're going to have 5 times 1 plus 3 for our equation. Okay, that's all that all of this says. So we're going to skip that for now. And then there's just a caution here. We pronounce this as f of x. It does not mean f times x or f multiplied by x. It is just f of x. All right, it says the graph of a function is a picture of the function's ordered pairs. For each function, evaluate f of 0 and f of -2. We're going to go through this first example together. So first thing we're going to do is f of 0. We can see that 0 is replacing x. So on the other side of my equation, wherever there's an x, I'm going to write a 0 instead. Okay, if I evaluate this, -2 times 0 is 0, plus 1 tells me that f of 0 is equal to 1. Okay, let's do the same thing with f of -2. So on the other half of my equation, wherever there's an x, I'm going to write a -2 now. -2 times -2 is 4, plus 1 tells me that f of -2 is equal to 5. Okay, try part B on your own, come to class with those answers. We will do C together though. So we're still trying to evaluate f of 0 and f of -2, but this time we're given a graph instead of an equation. So recall that 0 and -2 are in place of x here. So what we want to do is go on our graph to where x equals 0, and we'd like to figure out what our y value is. So I'm going to go up to my graph, and I have a point right there at x equals 0. My y value at that point is 4, which means if I were to have an equation for this and I plug in 0, I'm going to get 4 out. So 4 is my value there. Same thing for -2. I'm going to go to where x is -2. I'm going to go up to my graph, and I'm going to place a point there. The y value of that point is my solution. So at x is -2, my y value is +2, which means f of -2 equals 2. Okay. In the notation f of x, f is the name of the function, and the output f of x is called the dependent variable because it depends on the input value of the function. The input value, x, then, is called the independent variable. When a function is graphed, the independent variable is always graphed on the horizontal or the x-axis. And the dependent variable is always graphed on the vertical or the y-axis. Okay, and you can see that that is labeled over here in our graph as well. All right, a function whose graph is made up of unconnected points is called a discrete function, while a function whose graph is made up of connected points is called a continuous function. Okay, let's look at some examples. So we are given f of x equals 2x plus 1. We want to fill in this table and graph it. So I'm going to pick some x values. I'm going to have, let's do -2, -1, 0, 1, and 2. Okay, my x value is -2, so wherever there's a wherever there's an x in my equation, I'm going to plug in -2. So I have 2 times -2 plus 1. 2 times -2 is -4, plus 1 gets me -3 for my output value. Right, I'm going to plug in -1 now for x here. 2 times -1 is -2, plus 1 is -1. Let's keep repeating that process. Plug in 0 now. I'm going to get 1. Plug in 1. I'm going to get 3. Plug in 2, and I'm going to get 5. I did that super duper fast, so if you need to pause here and take a look at that work, go for it. Now on my graph, I'm going to look at my x and my f of x column, and those are going to get me my ordered pairs. So first I am going to plot the point -2, -3. Right there. I've got -1, -1 next, 0, 1, 1, 3, and 2, 5. And hopefully we're a little bit comfortable with graphing and plotting these points from Algebra 1. Okay, in this case, right, we only plugged in integer values for x, but I could plug in any number in for x here, right? I could plug in 2.529, -1245.5, right? I could plug in whatever I wanted here. So I'm going to say real quick, I'm going to note that I could plug in any real number here for x. What that means is that this is going to be a continuous function. So I want to connect all of my points with a line. Okay. If we look at this example here, we are given a mapping diagram. It says that if my input is 3, my output is 2. If my input is 5, my output is 6. An input of 7 gets me 10, and an input of 9 also gets me 10. Okay, I'm going to plot these points as well. So 3, 2, 5, 6, 7, 10, and 9, 10. Okay. As far as we know, we can't plug in any number here, right? Our mapping diagram only shows us that these are my input values and these are the specific output values I get. So all I can do on this graph is plot these specific points, meaning that this is going to be a discrete function. Okay, let's go through this last example together. So it says a local print shop will develop and print the photos from a disposable camera for 27 cents per print. Write a function to represent the cost of photo processing. First, we need to define our variables. So I'm going to say let, wrong marker. Let x be the number of prints. Then I'd like to write a function, so I'm going to call this f of x. It says that it is 27 cents per print. It doesn't say anything about like a flat fee or anything just for going into the store. So that means we're just going to take 27 cents or 0.27 and multiply it by the number of prints you want. So by x. That's our whole function there. B asked, what is the value of the function for input of 24 and what does it represent? So first let's do the math. We would like to find f of 24, which means in place of x on this side of the equation, we're going to write 24. So I have 0.27 times 24. Plug that into your calculator and you should get 6.48 out. Okay, what does this mean in the context of the situation? Well, we said that x is the number of prints. So since we replaced x with 24, that means we're getting 24 prints. And the output in this case is our total cost, right? So this means it will cost $6.48 to print 24 photos. Okay. Part C says, is this a discrete or a continuous function? If we're just looking at our equation, we would think that this is continuous, right? Any x value could go in there. Doesn't need to be an integer value, right? However, if we're thinking about the actual situation, could you go in and ask for them to develop 2.5 photos? I would say no, that doesn't really make any sense. We can only print whole number of photos, right? So that means that this is a discrete function, and we'll make a note there because we can only print whole numbers of photos. Okay, and recall whole numbers would be 0, 1, 2, 3, so on and so forth. Okay, that's the video for today, y'all. See you in class tomorrow.